this video, we're going to be looking at some examples of using the Pythagorean theorem to find a missing side length in a right triangle. So for each of these, we're going to find the value of x. Then we're going to determine whether the side lengths form a Pythagorean triple. So when I'm going through these, the first thing I like to note is which one's my hypothesis, because I know with the Pythagorean theorem, which again is a squared plus b squared equals c squared, my hypotenuse is my c. So it's going to be the one that's by itself in the equation. A and b, it doesn't matter which leg I assign as a and b, it just matters with my c. And so I know my hypotenuse is that side that's opposite of my right angle. So I look at my right angle here and I draw an arrow and I see that x is my hypotenuse. So when I go ahead and plug my information into my Pythagorean theorem, I have 5 squared plus 12 squared is equal to my hypotenuse squared, which is x squared. And then from here, I'm going to go ahead and simplify. So 5 squared, I get 25. 12 squared, I get 144. 25 plus 144, I get 169. And then to get rid of that square, I just need to take the square root of both sides. And I get that 13 is equal to x. And then the second part asked me to determine whether the side lengths form a Pythagorean triple. And so we talked about that in the last video. And I see that my side lengths are now 5, 12, and 13. And so I see that's actually my second Pythagorean triple, 5, 12, and 13. So the answer here is yes. However, if you do not have that table on hand, anytime that you end up with an integer, so there's no fractions, there's no decimals as your side lengths, then it's going to be a Pythagorean triple. So here, since I just have numbers 5, 12, and 13, that's going to be a Pythagorean triple. If this instead was the square root of 15, it wouldn't be. Okay, let's try another one. So here I have this right triangle, 7, x, and 14. I know to find a missing side length, I am going to be using my Pythagorean theorem. So a squared plus b squared equals c squared. My first step is to identify what my hypotenuse is. And so I look at my right angle. I know my hypotenuse is on the opposite side of that. So I draw an arrow. And so I see that 14 is my hypotenuse. So that means x and 7 are my legs. So I'm going to go ahead and just have a be 7. So I have 7 squared plus x squared is equal to my hypotenuse squared, which is 14. And then simplifying from there, 7 squared, I get 49. And then 14 squared, I get 196. Subtract 49 from both sides. And I get 196 minus 49 is 147. And then from here, I'm going to take the square root of both sides. And so for these problems, I am going to want you to write these in simplified radical form. So I'm going to go ahead and simplify this radical. I see it's not even, so I can't break it into 2. However, I see 1 plus 4 is 5, plus 7 is 12. And 12 is divisible by 3, so that means that 3 goes into this. And it's going to be 3 times 49, gets me 147. And then I see that 49 can be broken down 7 and 7. And so I see this can't be broken down any further. I do have a pair of 7s that come out. So x is going to be equal to 7 times the square root of 3. Now I need to determine whether this is a Pythagorean triple. Well, my side length does have one side length that has a square root in it. So the answer here is going to be no.